Hello everyone, welcome to Nishta IAS Prelims Express Geography Day 1. Friends, we take up the geography topics and I hope all of you are watching the videos and enjoying them, and don't forget to take the test regularly, and that is a very important part of your preparation. And then coming to the topics, friends, as usual in geography we don't have so many current topics, but what all topics which are important, where the questions have been asked, so we will take up them, and where you tend to make mistakes, we will discuss on those nuances, because now there is no point in discussing the latitudes and longitudes. Friends, all longitudes have same length. Yes friends, so here we have all longitudes having same length, that is they start from one pole and they end at the other pole. And then we have all lengths of the latitudes decrease from the equator. So the equator is the longest latitude, that is the 0 degree latitude, and at the poles we have only the point size latitudes. So hence the length of the latitude decreases from equator to the poles. And then we have the distances. The distance between the longitudes is highest at the equator. Friends, here we can see the distance is highest at the equator and it is almost 0 at the poles because they merge at the poles. Yes, and now coming to the latitudes, the distance between latitudes is highest at the poles. So here we can see the distance between two latitudes here, and we can see the distance between two latitudes here. So which is of more distance? So this is of more distance and this is of less distance. And as and when we move from equator to poles, the distance between the latitudes increases because the slope becomes less steep and hence the distance increases. So remember these nuances while catering to the exam. And then the international date line. Friends, we know that we have the prime meridian which passes through the Greenwich city, and then we have the international date line that is opposite to the prime meridian. And here we have the concept of the losing and gaining the day. So friends, when we speak about losing or gaining the day, we should also think about adding and subtracting the date. In some books they have given about adding and subtracting the date, and in some books they have given about losing and gaining the day. We will see how both the things are same, and we will see how the gaining and losing of the day happens. Say for example, here we have the international date line. On the one side we have Russia, Japan, etc. So remember that Japan people, they are fast forward. अभी जापान में 10G चल रहा है, so might be like they are much forward than us. And say USA people, they are not so forward, वो पीछे है, they are lazy people, they are only concerned about war and bombing. Now we take up one day, that is your Happy New Year, January 1st. So now we will see that the sun rises in Japan on the New Year. So now Japan celebrates Happy New Year. So then the sun rises in China. China celebrates Happy New Year. And slowly the earth keeps on rotating. So now here sun rises in India. India celebrates Happy New Year. And the same way Saudi Arabia. So now Saudi Arabia disappears from our picture. So in Saudi Arabia Happy New Year occurs. And then we have UK. In UK Happy New Year occurs. And then again in America Happy New Year occurs. So now in Alaska Happy New Year occurs. So friends, now when Alaska is celebrating Happy New Year, so now the very moment when the sun shifts to the other side, we get January 2 here, not January 1. So January 2 comes here as and when the sun shifts, so then the day changes. Say now for example, a person who moves from Alaska to Japan or Alaska to Russia in this fashion, so now he has to celebrate Happy New Year on January 1st. But as he moved to Russia, so now he will skip Happy New Year at that year. That means he wanted to celebrate January 1, but he shifted to Russia. Immediately he landed on Russia, and thereby he is experiencing January 2 and not January 1. So that means he lost the Happy New Year, and that means he loses one day. And as he loses one day, but come to the date of the calendar. Now January 1 was his date, but automatically it became January 2. That means January 1 got added with one date and it became January 2. That means as and when I shift from Alaska to Russia, I lose one day or my calendar get added with one date. So remember, losing a day and adding a date. So these are two different, but the concept is same. Yes, now coming to the vice versa. Say for example, now I am in Japan. I had celebrated January 1st, Happy New Year हो गया, केक वाक काट दिया, and then now I shift to Alaska, and then when I shift to Alaska, now I got the New Year again, दोबारा केक काट रहा है. So that is like the day got added to me. So that means the New Year day was a gain for me. I gained a day as and when I shifted from Japan to Alaska. So now as and when I gained a day, so now come to the date. Say for example, I gained one day here, but at the same time I wanted to experience January 2, but one date got subtracted to me and I was again to January 1 again. So that means when I gain a day, I get one date subtracted from my calendar. Friends, in NCERT and GC Leong, they are given in terms of day and date separately, so don't get confused. This is how the concept occurs. But for the exam it is concerned, remember that Japan people are forward, and obviously say the new year goes early for them and new year comes late for America people. So if you remember that, it will be very much easy for you to answer the question. So here we have the question of previous year. Another in Siberia, that is in Russia, are a few kilometers from each other. But when the people are walking up and getting set for breakfast in these cities, it would be different days. Obviously, they are separated from the international date line and hence they have different dates. And then when it is Monday in Anadir, it is Tuesday in Nome. Friends, they are saying that in Anadir in Siberia it is Monday. And now say Japan people are fast forward, so it has to be Sunday in Nome. It is not Tuesday. So this is wrong statement. You will get only one as the answer. So remember that this is a 0.5 seconds question if you are that cutting edged to the exam by preparing to all the concepts. If you go to the exam and then start jumping here and here, I am here, so now I went here, New Year celebration. So that is not the way to think in the exam hall. You should be very quick enough. So that is why very precisely remember that Japan people are fast forward. Then come to next, the Earth's rotation around its axis. Friends, here there was a question which asked that, say because of the climate change and melting of glaciers, the Earth's axis of rotation is changing. And here I have a data of NASA which said that Earth's axis is shifting because of the climate related changes. So to some extent it is shifting, and here melting of ice sheets, diminishing of groundwater and sea level rise. So these are the reasons for them. And now here there is a question which was directly asked. Scientific studies suggest that a shift is taking place in the Earth's rotation and axis. And why? Because the statement 2 says solar flares and associated coronal mass ejections bombarded the Earth's outermost atmosphere with a tremendous amount of energy. So friends, here the solar flares and the coronal mass ejections, they are only the charged particles or might be the intense electromagnetic radiations. So they don't change the density of the Earth or the distribution of the density of the Earth. As they are not disturbing the density of the Earth, they will not be having any part in the rotation of the Earth. Yes, so now coming to the third statement. So here the third statement says there is shifting in the Earth's rotation and axis because as the Earth's polar ice melts, the water tends to move towards the equator. So here the density is different. So friends, here the distribution of density is changing, and this can be the reason. Yes, likewise. So hence whenever there is difference in the distribution of density, so friends, actually Earth has been in the shape of geoid, and the density is evenly distributed so that it rotates like a sphere. But here the mass from the pole, that is the polar ice, it is being melting and it is transferring to the equator. Obviously there will be shift in the densities, and might be the axis might also shift on these lines. Now that part of climate change we understood, but here we have to understand the solar flares and coronal mass ejection. Friends, whenever the solar flares come, these are the charged particles or might be the electromagnetic radiations. When they come across these magnetic lines of the Earth, as we have seen in the figure, these magnetic lines, they guide these particles to the poles, because at the poles the magnetic lines are very stronger. So you take any bar magnet, so we have more magnetic lines at the poles, because at the poles, say the magnetic field is very stronger. Hence all the charged particles, they move towards the poles here. And as and when they move towards the poles, these charged particles, they interact with the atmosphere's charged particles. That means in atmosphere, friends, we have nitrogen and oxygen ions, and these charged particles of the solar flares, they interact with the nitrogen and oxygen ions, and it creates a plume of light around the poles, and that is why they are famously called as aurora borealis and aurora australis. So remember that the solar flares and coronal mass ejection, they can interact with the charged particles only. They can cause auroras, or might be they can disrupt the internet connectivity, or might be the telecommunication, or might be the satellite communication, etc. But they will never impact tsunamis inside the Earth. They never impact the Earth's rotation and revolution in any case. Yes, so to that extent, so here we can see that, here we can see the difference between the solar flares and the shifting of density of the Earth. And then we have, and friends, then we have the Earth's rotation and the direct sunlight. Friends, here we can see that the seasonality, that is summer or winter, is only because of the tilt of the Earth in its axis. So here we can see the Earth's axis has been tilted. So this is the tilt of the axis, and as and when the Earth moves, friends, the tilt will be same. It is never that when the Earth moves from this position to this position, the tilt changes. That will never happen. So remember that carefully. And here we can see that when the Earth is in the equinox position, So the direct sun rays is passing on the equator only. So the equator is having the direct sun's rays, and the Tropic of Cancer and Capricorn, they are having the slight direct sun's rays. Hence the illumination is exactly in the middle. But when you come to the solstice here, so here the illumination changes. The ring of illumination you can see in this yellow mark, and here we can see that the Tropic of Cancer is having very good illumination. Equator is not having so much of illumination, and Arctic Circle is having very much illumination. Because of good illumination of your Arctic Circle and Tropic of Cancer, for that matter, hence the length of the days in the northern hemisphere are more, and the length of the days in the poles, it is 24 hours day, because fully illuminated here. And hence we can say that whenever the earth is in the June solstice, so then the Tropic of Cancer and the Arctic Circle, they have the length of the day more than 12 hours. And coming to this position, that is the September equinox, so we have the other side of the earth which is being exposed directly, and here also it is exposed directly on the middle, and hence it is equinox, equal days and equal nights. And coming to the December solstice, friends, what we had experienced for the Tropic of Cancer and Arctic Circle in the June solstice, the same experience we have for the Tropic of Capricorn and the Antarctic Circle during the December solstice. So hence, in the December solstice, the Tropic of Capricorn and the Antarctic Circle, they receive the length of the day which is more than 12 hours, and in the South Pole, we have 24 hours day, because the whole region falls in the illumination ring. And by this we can analyze and answer this question on June 21 every year, which of the following latitudes experience the sunlight for more than 12 hours. So obviously here, the Tropic of Cancer and Arctic Circle are the answers. So hit 2 and 4. Many students hit 2 only as the answer, and they made a mistake. Make sure that you imagine the things properly. Don't by heart the things. Yes, so these are very easy questions, but people tend to go wrong here. And coming to the revolution of the earth around the sun. Friends, usually it is said that the tilt of the earth in its axis is the only reason for seasonality. And the distance of earth from the sun is never a reason for seasonality. If distance of earth from the sun was the reason, so here we can see the perihelion position, that is the earth is at the nearest position to the sun, and here we have the aphelion position. In the aphelion position, the earth is at the farthest position from the sun. So in that case, perihelion should have the hottest times of the earth, and aphelion should have the coldest times of the earth, because the sun rays, they take time to reach this distance, but they reach readily in this distance. But actually speaking, when the earth is in the perihelion position, earth is having the coldest days in the northern hemisphere, that is winter goes in the northern hemisphere. At the perihelion position every year, we experience the December solstice. So this defies the concept that the earth is having an experience of the sun because of its distance from the sun. It is never the case. It is always the tilt of the earth's axis with respect to sun is the reason for the seasonality and not the distance. So remember this concept very carefully. And then coming to next topic, isotherms. Friends, isotherms is a very simple concept, but the questions asked are not that simple. So here we can see the isotherms. That means the points on the earth which coordinate for the same temperature. So here we have the 0 degree isotherm, or maybe the 5 degree isotherm. That means throughout the earth we have 5 degree on this place. And apart from isotherms, we also have isobars. That means these are the points on the earth where the atmospheric pressure is same. And we have the isoclines. These are the points of the earth where the salinity is very same. So hence, by definition of these terms, we can also deduce the concept. So here there was a question which is asked that in January in the northern hemisphere, the isotherms bend equatorward while crossing the landmass and poleward while crossing the oceans. So I am sure that you didn't understand the question. And friends, it was asked consecutively for 2 years, and people, they left both the years. And now we will discuss how this actually works. So here I have a concept. Friends, this is the northern hemisphere, and we are taking the January times. And in January we have the winter, and here I have 2 land masses that are going on. And in the land mass, the earth is very cold and the temperature is very low. But the ocean waters, so this is very warm, because water, it holds the heat for longer duration. So land heats up and cools up quickly, but water heats up and cools up slowly. So now I take one point here. So say this point is coordinating for 0 degrees Celsius, and now I move from land and I cross the ocean. As and when I cross the ocean here, so now the water is warmer than the land. So here I say that the point is not at all 0 degrees Celsius. It might be more than 0 degrees Celsius. I take it as 10 degrees Celsius approximately. So now I want an isotherm here. For isotherm, I want to check 0 here. So for checking the 0 at this point, I have to move towards pole, because if I move towards equator, I will get 20 degrees Celsius, which is hotter than 10 degree, which I don't want. So I move towards the poles, and at this point I got 0 degree, and this is the isotherm for this point. And now as and when I move towards the land again, so I crossed this part, and at this point I am sure that, so I don't get 0 degrees Celsius here, because land is much cooler than the water in the winter. And now here I get say minus 10 degrees Celsius, and now I want 0 degrees Celsius because I am searching for isotherm. So I want to move equatorwards for 0 degrees Celsius from minus 10 degrees. So I came here. So now at this point I got the 0 degrees Celsius. So this became the isotherm here. So now we will read the question after analyzing this diagram. In January, in the northern hemisphere, the isotherms bend equatorward. Isotherms bend equatorward while crossing the landmass. I crossed the landmass here, and the isotherm bent equatorward, and poleward while crossing the ocean. So when I am crossing the ocean, so obviously isotherm bent poleward. So this is correct. And why this happens? Because in January the air over the oceans is warmer than that over the land masses in the northern hemisphere. Obviously the air over oceans, they are warmer and the land is cooler. So A is the answer. So hence if you learn the concept, obviously this will be very easy, friends. Geography questions are the must given concepts wherein you can take full bounty of questions. If there are 5 questions, you can make it all correct. Say for example in Lok Sabha elections, if UP and AP they gave full majority during Congress tenure, Indira Gandhi's tenure, Uttar Pradesh and Andhra Pradesh, they gave full majority to Indira Gandhi. Obviously she won. And now for Modi government, UP is giving full majority and AP couldn't because of the partition of Telangana. Hence geography conceptual questions are like UPs for your election into UPSC. So make sure that you are very thorough with that. And then we have the pressure belts. Friends, obviously you have learnt about the pressure belts very much, and now we can see how the pressure belts can be asked in the questions in UPSC. So here we have the low pressure belts at the equator, and in the low pressure belts, so we have the convergence of wind at the surface of the earth, and from the surface the wind rises up as shown in the figure, and then it diverges above the earth's surface. So now as and when the air rises in the atmosphere, so now this causes heavy rainfall on the equator, and now on the upper atmosphere the air diverged and then it reached the high pressure zone, and in the high pressure zone, so now the wind descends downwards. And friends, when the wind descends, so then we have the anticyclonic or the cold dry temperatures and seasons, and here we have the dryness and coldness. Yes, likewise. And now coming back to the equator, friends, in the equator, as we have the rising air and we have rainfall throughout the year, so the air's direction is very turbulent, and that is why this region of equator is called the doldrums, because when the ship sails in this region, so they will be confused where to go and which direction to go, and that is why they are called doldrums, very turbulent winds. And coming to this high pressure zone, friends, here the wind will be descending and the wind will be very peaceful, but at the same time wind will not blow in one direction, and again the ships get confused to sail, and as there is no wind, some of the heavy ships they start sinking. So to avoid sinking, so they have to lighten the ship. So now they will throw some of the horses which are there in the ship to the sea to lighten the ship, and that is why these latitudes they are called horse latitudes. Earlier horses were those animals which could be thrown to lighten the ship. Obviously we cannot throw human beings. Yes, likewise. So remember doldrums and horse latitudes here. And along with these pressure belts, there was a question which was asked. Say here the statement 1, the amount of dust particles in the atmosphere is more in the subtropical and temperate areas than in the equatorial or polar regions. Friends, in the subtropical and temperate areas, we have the descending winds and we have the cold dryness. Whenever we have dryness and no moisture, friends, the dust particles are very high. Why there is more air pollution in Delhi and why not in Tamil Nadu? Because in Tamil Nadu it rains heavily and the dust particles precipitates along with water droplets. But in Delhi that doesn't happen. Hence the statement 1 is correct. And coming to statement 2, the subtropical and temperate areas have less dry winds. No, they have more dry winds than lesser dry winds. And in the tropical we have less dry winds because of heavy rainfall. So statement 2 is wrong. Our answer will be C. So such simple questions will be asked we should be very thorough with that. Yes, likewise. Then coming to the Coriolis force, friends, we all have learned that this Coriolis force is because of the rotation of the earth. So here we can see the direction of rotation of the earth, and the Coriolis force acts towards our right in the northern hemisphere and towards our left in the southern hemisphere. So now here there are other factors which can add or delete the Coriolis force. So now here we have the question saying the Coriolis force increases with increase in the wind velocity. Friends, obviously the Coriolis force is because of the motion of the earth. And now when you are in the motion in the earth, so then the speed of your motion is directly proportional to the Coriolis force. The more faster you are moving, the more likely you are deflected by the Coriolis force. The more faster you are moving, the more deflection will happen because of the Coriolis force. And that is why, say, wind is also moving, and a moving wind is more likely to be deflected more rather than the stationary wind. Hence, the Coriolis force increases with the increase in the wind velocity. Friends, some of the students asked me a question saying that, say, the Coriolis force is deflecting in this direction, but the wind is coming in the opposite direction. So obviously the wind is cutting down the velocity. It is not increasing the velocity. So friends, this is the exception. It is not an example. Because, say, whenever the wind blows, it blows in all the directions. It blows in this direction also and the opposite direction also. So just because one direction of the wind is cutting down, we cannot say that this direction of the wind is not adding to the Coriolis force. Obviously, there is always an adding, but subtraction of the speed can also happen because of the opposite wind. So hence, this statement can never be wrong, but there can be exceptions to this statement. So remember, exceptions are not examples in this nature. And then, it is maximum at the poles and is absent at the equator. Hence, we all know that Coriolis force is towards the right in the north and left in the south. But what is at the equator? There is no Coriolis force because right and left they cancel out. Yes, so these are very simple questions. So if you analyze them, so we can get very good marks. Then we have the P waves and S waves. Friends, very easy questions came from these. If you analyze the concept, so then it would be very easy for you. We have two types of waves, that is the longitudinal waves and the transverse waves. Friends, I am speaking of the physical waves, that is motion of the physical particle I am speaking about. Now I am not speaking about the electromagnetic waves, where the electric field and magnetic field, they converge to form a wave. Here the motion of particle is a must for the wave to propagate. So here we have a longitudinal wave. In the longitudinal wave, the direction of the motion of particle is same as the direction of propagation of a wave. So the best example of longitudinal wave is, you have seen in the Instagram reels, people will arrange the stack of cards and they will make one card to fall on the other, and in a row all the cards fall down. So this is the best longitudinal wave we are being propagating in the nature. So because the direction of motion of particle is same as the direction of motion of the wave. Yes, likewise. And we have another set of wave called the transverse wave. Friends, here in the transverse wave, the direction of propagation of the particle is perpendicular to the direction of propagation of the wave. Here we can see the particle is moving up and down, but the wave is traveling from left to right. And friends, the best example for this transverse wave is the rope which you do in the gym. So here you take the rope and move it up and down, and for the hook, the wave travels in this direction and comes back. So the direction of wave is in this direction, right to left, and the motion is in this direction, up to down. So now, learning what is a longitudinal wave and what is a transverse wave, now we come to one concept. Friends, here I have the people who are standing in this fashion. So now what I do, I push this person, and this person falls on this person on this, and now the wave propagates. So now the direction of motion is same as the direction of propagation of the wave. So I successfully traversed a longitudinal wave. And now I catch hold of this person and I shake him left and right. Or might be if I am strong enough, I will shake him up and down. So if I shake him left and right, so he will not transfer any energy to this person because these two people are not connected to each other. So if I shake him left and right, only he will shake, and that will not make the others to shake at all. So now what I have to do? So come to this pattern. So here we have the people standing with their hands caught with one another. And now if I shake him left and right, obviously he will transfer the wave, and this person also moves. This person also moves left and right. This person also moves. Now the wave is propagated. Here the lesson we learn is, for the longitudinal wave to traverse, so there is no necessity that the molecules are attached to each other. Even if they are attached, the longitudinal wave traverses. Even if it is not attached, the longitudinal wave travels because one ball hits the other. And even if they are far enough, so even then it travels. So if the force is enough to hit the consecutive balls or consecutive molecules. But whenever you are propagating a transverse wave, so you have to have a mandate that the molecules are connected to each other. If they are not connected to each other, so you cannot propagate a transverse wave. Yes, remember very carefully, for a longitudinal wave, they will travel in all mediums. But for a transverse wave, you have to have a solid medium. In the liquid and gaseous medium, the molecules are not connected to each other and you cannot traverse a transverse wave there. Yes, likewise. Now, coming to the questions, in the seismograph, P waves recorded earlier than the S waves. Friends, P waves are nothing but your primary waves, and primary waves come first, obviously. That is a very easy question. So first statement is correct. And then in P waves, the individual particles vibrate to and fro in direction of the wave propagation, whereas in the S wave, the particles vibrate up and down at right angles to the direction of wave propagation. Yes, friends, in the earthquake, the P waves are the longitudinal waves and the S waves are the transverse waves. Hence, the S particles, they vibrate up and down, which is at right angles to the propagation of the motion. So hence, for this question, we obviously have 1 and 2 both as the answer. And now, coming to the same concept, here we have the P wave and S wave shadow zone. Friends, we all know that P waves are the longitudinal waves, and these longitudinal waves, they are born at this epicenter, and these longitudinal waves are born from the earthquake zone, and then they travel all around the earth, and they pass through the earth's crust, which is in solid, and as and when they enter the mantle, which is in the liquid state, the P waves, they travel through the liquid, but they get deflected. So the direction of P wave has to be this one, but after entering the mantle, they get deflected and they come here. And obviously, because the speed at the mantle is less for a longitudinal wave, so the deflection occurs, and anyway, the waves manage to come to the other surface despite deflection. But coming to the S waves, friends, S waves are propagated from the earthquake zone here again, but as and when they pass through the mantle, they get dissipated. So that is why once they cross the mantle, the waves die down. They will not pass at all. Hence, in all these regions, that is, we have the S wave shadow zone because the waves die down, because they can't travel through the liquids and gases. So I hope now you got the reason why there is a S wave shadow zone which is very big, but the P wave shadow zone which is very small. P wave shadow zone is because the waves only deflect. S wave shadow zone is because the waves completely die down. Yes, likewise. So remember such concepts, they will be very tricky. Then continental drift. Friends, plate tectonics. Then here the folding, faulting, transform boundary interactions. So all these are not asked by UPSC now, and might be in the past they have asked too many questions and hence they have become saturated. And here I have a question on continental drift. That is, the belt of ancient rocks from the Brazil coast matches with those from the West Africa. Then the gold deposits of Ghana. Friends, Ghana is in West Africa. They are derived from Brazil Plateau. The two continents lay side by side. Then Gondwana system of sediments from India is known to have its counterparts in 6 different land masses of the southern hemisphere. Friends, for this, if you learn this diagram, that is more than enough. So here we have the Pangea, and so this Pangea divides and it forms the world. Here we have Eurasia, and then we have North America. Friends, here we can see the Greenland. Greenland is very much in news because of geopolitics. Remember, Greenland is a plate which got separated from North America itself. And then we have Africa here, and then we have Arabia. Friends, Arabia also got separated from African land. And then we have South America. Then we have Madagascar here. Then Indian plate, Australia and Antarctica. So to that extent, whenever we consider the southern hemisphere landmass, India is connected with Africa 1, Arabia 2, South America 3, Antarctica 4, Australia 5 and Madagascar 6. So that is why we have 6 plates which are connected to India in the southern hemisphere. So here we can see them clearly. So India is 1 here, 2, 3, 4, 5, 6. They have been shown very clearly. And so this Gondwana plates and Laurasia plates, so they form your North America, Eurasia and the southern hemisphere land masses. And this is the original world map as of now. And here a small figure shows the folding of the plates and the subduction of the plates and the transform boundary interactions. So anyways, so now we got the answer how the 6 plates exactly. Friends, some people said that, sir, in UPSC any data which comes is wrong. So 6 is a data, I put it wrong. So don't do that, because such illogical guesses will not yield good marks, and there are always risks of that. Say for example, the paper is actually tough, and now you are forced to attempt because there are so much of data here, and you keep cutting down all the facts and statistics, and invariably you end up attempting more and get more negatives. That is why if the data is very practical, don't hesitate to make it correct, and if the data is very extreme, so don't hesitate to make it wrong. So go with that knowledge based logical guesswork, not the illogical guesswork. And some students have said me, sir, so if there is double line space here, answer is C. So that will never be an answer, because the paper setter is different from the editor of this format, the formatter. So hence don't go for illogical guesses, and a logical guess is more than enough, and people are scoring 110 plus with this logical guess, and why unnecessarily go for those illogical things when the cutoff is in 90s. Then coming to next, intrusion and extrusion rocks. Friends, a very simple concept. Intrusion rocks are those rocks which get solidified slowly inside the earth. So these are the rocks inside the earth's surface. And then the extrusion rocks, these are the lavas which come out of the earth's surface, and they get cooled suddenly because of atmosphere, and because of sudden cooling, so the lava breaks and it turns into pebbles, small stones, and you don't get big rocks and boulders with these extrusion rocks. So remember that carefully. Intrusions are big rocks, extrusions are very pebbles. And in the intrusion rocks, we have so many other types. This is the photograph of G.C. Leong. You might have seen this. Here we have the intrusion rocks, which is on the layers, which is in parallel to the layers of the earth, and that is why they are called sills. And some intrusion rocks, they are not parallel to the layers of the earth. They are called the dikes. So friends, remember the sills and dikes. And remember batholith, the base stone which is very large. And friends, we have the saucer shaped intrusion rock, that is called the lopolith. So remember solo, that is saucer, and lopolith, solo for saucer, lopolith. And then we have the lens shaped rocks, that is the phacoliths. Friends, remember fallen, so phacolith for lens, fallen, so solo and fallen. And in the phacoliths which are lens shaped, we have anticlines and synclines. Friends, anticlines means, so these are the lens shaped ones which are forming the crest like structures, and the synclines are the ones which are forming the trough like structures in the earth's layers. And then we have lacolith, that is the mushroom shaped rock. Friends, remember lama, that is lacolith for mushroom. So if you remember lama, lacolith for mushroom, and fallen, phacolith for lens, and solo, saucer for lopolith. If you get confused, you can also add solopo. Hence, by making such mnemonics, it is very easy to understand. And friends, I don't know whether the questions appear from this, but always there will be a fear of missing out, that maine ratta nahi mara hai. So rather than by hearting again and again, make a mnemonic and remember that and move on. And then we have the soils. Friends, usually we have three types of basic soils. That is the sandy soil, which is very highly porous, and the grains are very large compared to the clay. And then we have clayey soil, where the grains are very fine grained, and here the permeability is very less, and the porosity is also very less. And in the sand, the permeability is more and porosity is also more. So porosity and permeability means the pores, the size of the pores, or the holes or the spaces between the particles, and permeability means the extent to which they allow the liquid to pass through them. They permit the liquid to pass through them. And we have the loamy soil, which is a mixture of your sandy and clayey soil. And then we have the silt. Friends, silt has the mixture of all the three, that is sandy, loamy and clayey soils. And these are the soils which are brought by the rivers. And river will not differentiate properly which is sandy, loamy or clayey. It brings everything all and sundry. But usually the very fine grained clayey soil, so that will be deposited, so that will be carried for longer distance in the river, and the others will be carried for lesser distance. Only that much separation river can do. But anyway, silt, although it has very fine grained clayey soil, it also has sandy and loamy soil also with it. So now we understood the permeability and porosity of the rocks. Here there was a question, in the context of the effect of water on the rocks, chalk is known as a very permeable rock, whereas clay is known as quite impermeable. Yes friends, if you put a drop of water on chalk, the water disappears into the chalk because it is highly permeable, and that is not the case with clay. So if you drop a water on clay, so the soil retains that water droplet. And so here the chalk is porous and hence can absorb water. So this is also correct, and it is a reason for the statement 1. And the third statement, clay is not at all porous. Friends, this is a very extreme statement, and cut this down, you will get the answer easily. And here I have to say that, friends, it is very essential for you to analyze which is a moderate statement and which is an extreme statement. If the statement was like this, clay is having very less porosity, it would have been a definitely correct statement. But not at all porous is completely an extreme statement. There was a question about small finance banks in UPSC some 7-8 years back. The statement went like this: the small finance banks are particularly located in rural areas. And I read that statement. I felt that, small finance banks are particularly located in rural areas only. I made it as correct. But as per UPSC, small finance banks are not particularly located in rural areas. They are generally located in rural areas. For UPSC, particularly was an extreme statement and generally is a moderate statement. So here, people who even did PhD on small finance banks, they made it wrong because they don't know that particularly and generally words is different for UPSC. So you have to learn the UPSC language. That is why analysis of PYQs is very must. Then coming to next, the layers of atmosphere. Friends, usually we have the troposphere. In the troposphere, we have most of the weather phenomenon. That is, the hot and moist wind rises up, it cools and it falls as rainfall. And friends, in the troposphere we have seen the lapse rate, that is, the temperature decreases as and when we move towards the height. And then we have stratosphere. Friends, in the stratosphere we have the ozone, and as we have the ozone holes are also present in stratosphere only, and that is why we have remembered the stratospheric clouds. So these are the main reasons. These are the crucial clouds which give space for the chlorofluorocarbon, which in turn will corrode the ozone. And apart from that, as there is presence of ozone in the stratosphere, so the temperature doesn't decrease with the height, rather it increases with the height in the stratosphere. That is why we don't have lapse rate, rather we have temperature inversion here. And when we move to the mesosphere, so there is no such ozone, hence we have the lapse rate as usual. But in the thermosphere again, rather than lapse rate, we have the temperature inversion, because in the thermosphere we have the ions, or thermosphere is also called as ionosphere. Friends, here in the ionosphere, because of charged particles, the temperature rises, and also that these charged particles, they are very much essential for satellite communication and also for the launching of space satellites. And then we have exosphere, which is almost considered as a space, and here we have the spaceships and the satellites which roam in this layer. And friends, most of your flights and others, they will travel only in the troposphere, and some of the weather balloons, they can lie in the stratosphere, and above the stratosphere only the satellites and spacecrafts, they can move. And here we can also see the auroras, they happen in thermosphere because the ions are more there. And then the meteors, mostly the meteors, they burn down as and when they enter the stratosphere, and they mostly get completely burnt by the time they enter troposphere. And only those meteorites which will not be completely burnt and which will fall to the earth, so they will enter the troposphere. So this is a brief explanation of the temperature layers, the atmospheric layers. And here we have a question, that is, the thickness of troposphere at the equator is much greater as compared to the poles. Friends, obviously it is. Say at the equator, the troposphere is very thick compared to the poles, because say at the equator we have the convectional air current, where the hot and moist air, so that will travel for the greater heights before it gets adiabatically cooled and it forms rainfall, and the rainfall falls down. But here at the poles the air is already cool, and it takes very less height to move up and get cooled and fall as precipitations. So hence the statement 1 is correct. And why the thickness of troposphere at the equator is much greater? Because at the equator heat is transported to greater heights by strong convectional currents. So because of strong convectional currents, the troposphere became thick at the equator and thin at the poles. So A is the answer. Hence it is a very easy question. And then coming to the last part, friends, this is the picture of Ernesto Che Guevara, that is the revolutionary of 20th century, and he was captured and executed by the capitalist forces in the year of 1967. And till 1997, his closest friend, that is Fidel Castro, he searched for his body, and he got his body cremated after 30 years in 1997. That means, friends, his body was searched by whole Cuban citizens and the nation for 30 years. And now imagine the government hospitals, there are so many dead bodies, and no one came to claim those dead bodies. Not even the children, not even the parents, or not even the relatives came. Why? Because this person, he did everything for the sake of people. and people always remembered them. And we people, we do only for our wives, husbands, or children, or parents, and no one will remember us. So it is good that you have to get a government job, you have to get a settled life. But after getting into the settled life, also think that this is not the way to settle. We have to do many things for the people who are not fortunate enough to come even to our positions where we are in. So if you do that, obviously you will have a fruitful life rather than being in a fruitful job. So keep such leaders in mind always and work for your life and plan for your life. All the very best from my side. Good luck, friends.